The Patriot ZLD model was very interesting because the president of the company, Gene Griffith, from the beginning, his intent was to run as a ZLD. Now that concept is interesting because why would somebody choose to operate that way that didn't have to? And that's why Patriot is a first, because they voluntarily set themselves up to operate as a ZLD. They weren't required to. They have an IPDES permit, which they maintain. But they chose to do that, and we'll talk about the reasons why here in just a moment. It's an ICN 100, and they purchased the property as you normally would, look for a site with good rail access, energy, gas, and so forth. But then they added the dimension of water, because there are people who have purchased properties and they did not have water sampling done. And there were some surprises. I know of at least 2 properties in the West Coast that were purchased with water analysis after the fact, and those sites could not run because either the water supply was unreliable or the water was just simply too aggressive to use. So Patriot looked for a site adjacent to good water. They actually purchased property, 29 acres, that had 3 wells. They ran pipelines from that property under a canal, under I-80, bringing that water to the plant. So a lot of thought and a lot of planning went into that water supply. They started up in August of 2008 with an IPDES permit from the state of Illinois, as I mentioned. They used under 1 million gallons of water a day at that time, and that translates to the industry average of 3 gallons per gallon of ethanol. So after all the performance requirements, warranty issues, all that was passed, late 2009, Patriot decided that we're going to go ahead and implement this ZLD process. Now, interestingly, in Illinois, if you're going to operate as a ZLD, you have to have a person certified and licensed on site to manage, because what you're doing is you're treating what they regard as waste. What would normally be discharge, you're now going to treat. And so the plant manager, Rick Bonder, went through the training required. He took the state test, passed with flying colors. He is the on-site responsible, certified, licensed operator of that ZLD. Not all states require that, but in the case of Illinois, that is what is involved. U.S. Water had done the original modeling, so what we did is came in, looked at the way the plant is running, how does it match the model. There were some slight modifications to the DCS. They were temporarily not using CO2, and if you're going to go ZLD, what you'll find is that you want to use plant CO2 for places that you can adjust your alkalinity and not use sulfuric acid. This is an example of a water balance that U.S. Water does. What we do is take each stream in the plant, the water supply, we analyze that water, and then we see where is that water going to go, how can we direct it to get the most benefit and use out of that water. Coupled with that, this is the PFD, or process flow diagram. We go to the next, don't worry about trying to read those details, but there's some 40 species of constituents in water that we analyze. We do a full set of tests, not just one, but several tests to make sure we get a good profile of that water. And then the columns that go to the right, every place in the plant that water is going to be used, we then take a look at what is that water going to look like at that step. What are the components of the water that are going to be a problem when it's used in the scrubber or goes to fermentation? We've got a number of factors we have to consider. This is just an extension of that. But looking at all those components, if you have high sulfate water, and now you take all those streams that would normally be discharged and you bring them back in the plant, well, guess what happens to that sulfate? It's going to end up in your co-product. If operators spill things on the floor, you have a spill inside the plant, anything that goes to the pad is going to end up going to process. It's going to end up in your co-product. So you look at everything, the chemicals you use, they have to meet the veterinary requirements, DVM, FDA. Anything you add to your process, it's ultimately going to end up in your co-product. So looking at all those things, by the way, it's sodium. You're aware that sodium is a stressor for yeast. All those things have to be analyzed, taken into consideration before you implement ZLD. You don't want to have a surprise where you kill a fermenter because your sodium levels were high, or have sulfate so high in your co-product that you now have difficulty selling it. And by the way, that's a reality. We have clients who are dealing with very elevated levels of sulfate, and they either have to lower their costs to move it, or they're limited to certain markets where the sulfate in the water is low. So all those things, silica hardness, we monitor those things. We did that at Patriot, looking over the system, and we implemented in February of 2010. Implementation was simple. Because it was part of the design, it's 15 minutes of opening 2 valves, closing 2 valves, and we took that water from discharge and put it back into the process. And with that, lo and behold, we were ZLD, very simple. Again, because it was incorporated into the original design. What we saw, and it was quite exciting, it was actually, I think it was like 1.99 gallons of water per gallon of ethanol. Like, wow, that's awesome. And what we found is with seasonal variations, we obviously evaporate more in the summer, so we're at, Rick is estimating 2.3 to 2.4. That's a savings of 100 million gallons a year. Now, what is 100 million gallons of water? What does that represent? Well, in the case of Patriot, it's all the water that the citizens of Anawan, the nearby town, that's enough water to supply the whole town. More than 1,000 families, more than the city of Anawan, but many of the farmers in that area. That water savings becomes a very good neighbor act on the part of Patriot. And the well tests that they do show that there's been no depletion of the water table. And what they're trying to do is be a good neighbor. Again, this was the first voluntary ZLD in ethanol. And it's in keeping with the company philosophy. It's been operating successfully. We're doing ongoing monitoring. I'll be there next week to do some follow-up. And we also want to be aware of any surprises, anything that's happening. And so it's an ongoing process, but interestingly, as I mentioned, it was accomplished voluntarily. It shows that the original design was sound. The investment by Patriot was valid. This is something they can use to demonstrate that they're a good neighbor as part of their corporate philosophy. And importantly, it's proactively ahead of the regulatory curve, because as these permits are being revised, and if you're not getting information back from the state, and they're telling you just keep going where you're going, it's because they're looking at these things, and you can bet that these are going to become more stringent. In the case of Patriot, they maintain that permit, although they are ZLD. If the permit became so restrictive that they couldn't use it, it's not a concern, because they're operating in that ZLD mode. So from the original concept to implementation, it was well planned, well executed. We hear that term poster child. If you want to say that there was a poster child for how to do ZLD right, it was the Patriot model. Right from the beginning, from concept, inception of the idea, all the way through execution, it was part of the plan. As a matter of fact, of all the ones I've been involved in, it's probably the easiest, most successful ZLD that I've been a part of. Some require, they're very stressful, take a lot of effort, a lot of capital, so this was a very nice project to be a part of. As I mentioned that term, the integrated approach, IZLD, when you look at a water system, if you're going to modify your system, make sure you take into account all the things that you can do within that plant. Use CO2. Another thing that we discussed with the EPA representative this morning, Rick and I, that they're going to be looking at CO2. And if you can take CO2 in the plant and use it to treat your water, well, that's going to be another greenhouse bonus down the road. So using that approach, U.S. Water has had a good deal of success in helping plants implement from the start, the original design. We've also been a part of many of these repairs that I referred to, fixing flaws. And we call it IZLD because we do the full survey, the full analysis, the study, the modeling, and just as importantly, we help the plant implement so that they have a successful outcome and successful project.